Welcome to the session. Kindly give me a confirmation if you guys can hear me. Good evening, everyone. Kindly give me a confirmation if you guys can hear me. Yes or no? Can you guys hear me? Yes or no? Perfect. So, good evening to everyone. Welcome to day 4 of this boot camp. Okay. So far we have understood about Python, the entire 3 days we have consumed for Python. Now we are going to start with something serious, that is your machine learning, right? But before going ahead, kindly give me a confirmation if my screen is visible to all of you and if you guys can hear me properly and clearly. Can you guys hear me clearly? Yes or no? And is my screen visible to you? If the screen is not clear for you, then kindly change your resolution to the higher ones. Okay? Is this clear? Perfect. Awesome. So now we have started out with Python. We have studied Python. We have understood what exactly are the pros of Python and cons of Python, and how we can use different data and data types in Python. What are different data structures in Python? How to use loops, right? What are the two types of loops, and how to let's say how to use the conditional statement. We have some keywords as if, else, and elif as well. Yes or no? Okay. Today we are going to start with the machine learning. Today we are going to understand about machine learning. What is machine learning? What exactly does it mean? And how we can use machine learning in a real life example, and why machine learning is so much popular nowadays. Okay, is this clear, everyone? Yes or no? Is this clear, everyone? Yes or no? Give me a confirmation, guys. Is this clear? Shall we start? Yes or no? Perfect. So let's start with our topic known as machine learning. Okay, machine learning. Now, if I ask you, what do you understand? What do you guys understand by the term machine learning? What do you understand when I say machine learning? What do you guys understand about the term machine learning? Come on, tell me. What do you understand by the term machine learning? Anyone? Anyone? Come on. Come on, guys. Tell me. Okay, people are saying that we give output and data to machine and generate a program. Okay. Okay. Machine work as human by learning AI and all that. Okay. Learn about machine language. Okay. Perfectly fine. So when we talk about machine learning, it means we are training a machine or training a computer so that it can do its task on its own. It don't needs to be dependent on human to perform. Right. Currently, if you see nowadays, when the machine has initially has been launched, any kind of machine such as your laptop, computer, and so on and so forth, what used to happen is that a human, it needs a human to operate it. It needs a human to operate it, right? If your human is not operating it or switching it on or so on and so forth, it will not going to perform any kind of action, right? So it uses a human interference, it uses the human supervision to perform. So machine learning is a field where we train the machine in such a way so that machine doesn't require any support from human. It just learn from its own past experience and will going to perform better and better, right? Now when we talk about these terms like machine learning, AI, and deep learning, what exactly are these, right? What exactly are these? So if I have to club this, I would say, let's suppose this is your AI. Okay, this is your AI. Then under the AI falls machine learning. Under AI falls machine learning. Okay, and under machine learning falls your DL, that is your deep learning. Okay, so if you see over here that deep learning is the subset of machine learning, and machine learning is a subset of AI. Okay, so many times what happens is people compares and get confused between AI and machine learning. They say that AI and machine learning are same, or they are not identical and all that. So there is a difference between AI and machine learning. That is, AI is the superset of machine learning, right? Whereas machine learning is just a subset or just a part of AI. AI is way more than a machine learning, right? Now, the entire prospection of AI, ML, and DL, or the entire motive is to create a human alike robot. Okay, we have humans, right? We have humans, right? What we do is we create a robot. We will going to create a robot that will going to act according to human, the way human talks, the way human make decision, the way human acts on various situations, right? So the motive of AI, ML, and DL will remain with the same, to create a artificial human being which we call as a robot, right? Now, ML totally focuses on the way how the human reacts and how the human learns. Okay, how we this human learn something and we act accordingly. Right, that's what is the area that machine learning covers. Right. When we talk about DL, that is a deep learning. Deep learning focuses on making or cloning a human brain. It works on a human brain. It checks how a human brain works, and based on that, it creates an artificial brain. So DL is based on that. Okay, deep learning is based on deep learning is based on creating a human brain, how to study the human brain, how it make decision, and so on and so forth. We are going to act like that, right? So this system, the human system is very complicated, right? Human doesn't follow any pattern. Human doesn't follow any pattern, right? Their decision changes based on situations to situation, right? But machine, what happen is, in machine, when we talk about ML over here, we always checks for a pattern. We always checks for a pattern and we act accordingly, right? But we know that human doesn't act and follow a pattern kind of stuff. So that's why we have introduced DL. DL is the a more advanced version of machine learning, where we focus in how in the cloning the human brain, and the motive will be how exactly human makes decision. Okay, how human makes decision. Let me give you a situation. Let's suppose uh, you are studying in a school, right? And you have given an examination, and the exam to get pass, okay, to clarify that examination, to qualify the examination, you need 40 out of 100. At least you need 40 marks out of 100, right? So what happened is, you got, let's say you got 39. That means you are failed, yes or no? That means you are failed, yes or no? If you are getting 39 out of 100, you are absolutely failed, yes or no? Come on, guys, tell me. Okay. Now, in a very general manner, we have defined a rule. We have defined a rule that, now see, we have defined a rule that any marks that is equal to 40 or greater than 40, we are going to consider this as a pass, and below than 40, we are going to consider this as a fail. This is a general rule that we have to follow. But now you must have seen that sometimes it happens that even though you have got 39, you go to your teacher and you tell him or her that kindly give me 1 marks, like a grace marks, right? Kindly give me a grace mark, so I will, I'm going to get pass and all that. Ever happened this with you? Yes or no? Ever happened this one, that you were failing by 1 or 2 marks, and you went to your teacher and telling the teacher that, kindly give me a grace marks, please pass me and all that, because I'm going to get failed by 1. So what happened is that many a time you get the grace marks, many a time you get a grace marks, many a time people, the teachers will going to give you the marks. Now, if it would be a machine, machine will not going to give you, or will not going to follow that. It will always going to follow this rule. It will always going to follow this rule. Is this clear? Machine learning or machine is always going to follow this rule. Doesn't matter how many times you are going to cry in front of it that kindly give me 1 marks extra and so on and so forth. It will not going to give it because it is going to follow this rule. However, when we talk about human, their decision changes based on the situation. Their decision changes based on the situation, right? So that's why we have AI, we have ML, and we have DL. So in this series, we are going to focus on ML. We are entirely going to focus on machine learning, that how exactly machine learning going to work out, what are the different algorithms that are in machine learning and how to perform those, right? Simply, if you talk about Tesla cars, right? Tesla cars uses the DL part, right? To clarify that whether there is any object in front of it, so we have to stop or not, right? So to understand human brain is very complex. Human brain is very complex to understand, guys, right? Because we don't follow a single pattern. We Our decision depends upon the situations, right? For an example, let me give you an example. Let's say this is a road, okay, and you are driving your car. Let's suppose this is your car and it is going from left to right. You're driving your car, right? And in front of your car, it happens to be, let's say we are having a dog in front of your car. Now tell me, will you going to stop your car or not? Will you gonna stop your car or not? Come on, tell me. Will you gonna stop your car? You're driving a car, and in front of that you found out a dog. Will you gonna stop your car? You will going to stop your car, right? See, so over here, over here we can say that if anything is coming in front of us, if any object is coming in front of us, we are going to stop the car, right? Now, let me take the same situation. Let's say this is your road. You are going to drive your car from left hand to right hand, right? Because you are stopping over here because it's an animal, right? At the same case, if I say you're driving your car and let's say an ant came in front of you. Now will you gonna stop the car? Now will you gonna stop the car if you find that there's an ant in front of you? Tell me. Now will you gonna stop your car? Tell me. No, right? Exactly. So you will not going to stop your car. So now see, we have the same scenario. In the same scenario, we are having an object in front of us, okay, and based on object we have made a decision that if this object occurs, we are going to stop. Now this is the rule that the machine will going to follow, okay. This is the rule that a machine will going to follow. However, human will going to take different decision. In the first case, even though we are having an object in front of us, we were stopping it, right? But in the second case, still we are having an object, we are not stopping. So over here you can see our decision differs from situation to situation, right? So that's why to understand the human brain, that how it makes a decision, it's very very complex. So that's why we have the deep learning studies and ML studies. ML is to understand the behavior of learning of human, right? Now when we this is an example of deep learning. Now when we talk about machine learning focuses on the human behavior, how they learn, how human learn, right? Let's say now if I ask you, tell me what comes after A, B, C. Tell me what comes after D. Now, if I ask you what comes after D, so it will be very easy for you to answer. Yes or no? Yes or no? If I ask you right now that what comes after C, it will be very easy for you to answer. Yes or no? Okay, perfect. But now, if I ask you the same question, how exactly we have learned that D will going to come after C? How exactly do we know? If I ask the same question to you while you were a child or you were a baby, like suppose you were 2 or 3 months old or 4 months old or a year old, if then I would have asked you the same question, do you think it will be easy for you to answer this one? Do you think it would be easy for you to answer this one? Come on, tell me. Yes or no? No, exactly. It will be very difficult for you. It would be very difficult for you. But now, if you see the time gap, how exactly do you know about this D? Because you have learned something over and over and over again. For the first time, it might happen that suppose you are a toddler, right? And your parents told you that this is how you write A. This is how you write A, right? Now they will going to give you a pen or a pencil and they will going to tell you that write A. Do you think this toddler will going to write A as perfect A, as a perfect A? Yes or no? Come on, tell me. Do you think the toddler will going to write this A perfectly on the first go? Come on. No, exactly no, right? So it might happen you could write like this is A for him, right? Then what happened? Again, the parents will going to tell him that no, this is not A. This is how you write it. So what happened for the next try? It might happen that the toddler will going to create A like this, and in next try they might it might him or she might get him he or she might try like this, and so on. So after try and try and try they will going to receive the perfect result, right? This is the entire uh, funda of machine learning. This is the entire funda of machine learning. Machine says that how human learns, we are going to take the same way. Human learns from its past experience. You write something, you have written something, and then you get it checked by your parents, right? Whether it's right or wrong. If it is right, then perfectly fine. If it is wrong, then you are going to do another try. Then you are going to do another try. You are going to learn from your past experience that this is wrong, I need to do this, right? Now when your parents say that okay, this is wrong, this is slightly wrong but better than before, but this is still wrong, again you will going to learn from your experience that this is wrong. Now, like doing this at some stage, if you reach like creating an A like this, right? Now when your parents will going to tell you now this is perfect, so what happened, this character will going to register in your brain that this is a perfect A. This is how you create A, this is how you pronounce A, right? So how exactly we the scientists and researchers have studied about this entire phenomena, and they have came out to be action that if the machine has to be smart, it first needs to learn how exactly human learns. So that's what is known as a machine learning, where it will going to learn from its past experience, and it doesn't require any of the human influences to learn something. Is this clear? Is this clear? Yes or no? Is this clear, everyone? Yes or no? Kindly give me a confirmation, please, if you guys getting this. Are you guys getting this? Yes or no? Come on. Perfect. Okay. So now, when we talk machine learning, nowadays a lot of people are using machine learning. They are using different algorithms to predict, right? If I talked about, let's say, bank, okay. If I talk about bank, right? Nowadays, what happened that when bank provide loan, when bank provide loan, now you must have heard about a lot of things that it says that if you should be having a good credit score in order to get a loan. Anyone have heard about this term credit score? Did anyone had heard about this term credit score? Anyone? Right? How exactly this credit score matter? How exactly this credit score matter? So what happened is bank uses machine learning algorithm. They have created a machine learning algorithm. And now what they do is whenever someone applies for a loan, they have even implemented this system in their application. If you go on Paytm has one a feature that if you want to purchase, you can get some money in a form of a loan for some time. Kindly, or some kind of website that states that provides some information and we're going to tell you either you are eligible for loan or not. You must have heard about these kind of websites, yes or no? Right? You must have heard about this website that states that kindly give us some information and we're going to tell you whether you are eligible for a loan or not, whether you are going to get a loan or not. Heard about that? I believe so. Right? So what happened is that all the banks have created a machine learning algorithm. What they do is they will going to take the user input, This machine will going to perform some analysis based on this input, and will going to give you an output whether or not this particular human is eligible for a loan or not. This is how. There's a lot of applications. There are a lot of applications. If you have heard about the application known as Grow, CoinDCX, Kuvera app, right? What they do is they are the stock market kind of apps. They say is the user that kindly deposit your money, and we have our own, you know, brokers. They will going to put your money in a different company, a good company, and then whenever they are going to get the profit, they will going to share your profit with you. How do they know that which company will going to which stock will going to rise or which stock will going to fall in the upcoming time? Because nobody can predict that, right? So that's why we uses the machine learning model. We feed the data. Okay, we feed the data and a lot of data. More the data, more better will be your accuracy for that, right? If you want to create a model that will going to predict the stock market, you can easily use machine learning to do so. Now the thing is, the word that is most related with machine learning is the word predict. And when we use predict, what will going to happen is one more word, that is the core word. That's the core word. It's known as probability. It is known as probability. I believe that everyone have heard about this term probability during their lifetime. Either it might be during your 10th, 12th, or in your college days, right? Whenever you have studied statistics, you must have heard about this term probability. Yes or no? Right? So when we talk about probability, probability gives you an estimation. Okay, probability gives you an estimation that what are the chances of the particular event to occur or not, or whether that event will going to happen or not. Probability will never going to give you 100% surety. Probability doesn't mean that I am providing you 100% surety that this will going to occur only. Probability will going to tell you a chance. If I say that, let's say on Sunday it was raining, on Monday it was raining, on Tuesday it was sunny, on Wednesday it was raining, on Thursday it was raining, on Friday it was sunny. And now if I ask my machine that kindly tell me what will be the weather, on Saturday, what will be the weather on Saturday? Will it going to rain or will it going to be sunny? So now my machine will going to give me a probability. My will going to say that, hey, there are 80% chances. There are 80% chances that there could be a rain, right? And there are 20% chances. There are 20% chances that it will be sunny. There are 20% chance it will be sunny. But this doesn't mean, when we say that there are 80% chance that it will be rain, it doesn't mean that we are saying that it will going to rain only. It doesn't mean that. Yes or no? Yes or no? Are you guys getting this? Are you guys getting this? When we say there will be 80, there is a 80% chance of rain, it doesn't mean that the rain will only going to occur. It can happen as it could be sunny as well, but there's a high chance. So probability will never going to give you a surety. Probability will never going to give you a surety. Probability will only going to give you the chance, that how, what are the chances of that particular event to be occurred, right? Similar case applied in machine learning. Machine learning will only going to give you the probability of something to happen. Okay, similarly you must have seen an advertisement of various various company tell you that a kind of antiseptic like Dettol kills 99.9% of germs. Lifebuoy kills 99.9% of germs. Must have heard about this quote. Yes or no? You must have heard about this quote. Yes or no? Are you guys getting this one or not? Come on, tell me. You guys must have heard about this quote that this antiseptic or this cream or this soap kills 99.9% of germs and so on and so forth, right? So over here, you will hardly going to find out. You will hardly going to find out, or you will never going to find out that any any company or organization claims for 100%. then we're never going to say that it will going to clear 100%, because by saying 99.99%, they are in a safer side. They are in a safer side because they know that when we are leaving, if suppose a person comes up with a claim, a person who comes up with a claim and he will going to say that, oh, I was using your product and I have got infection. I have got infection, but I'm using your product. In that case, company can say that we are only saying that there are 99.9% chances, but there's still 0.01% that you can get infected. Okay, still there is a chance. There is a chance. We are not giving you a surety, but we are giving you a probability that this is a probability that you will not going to be affected, but still there is 0.0% of chances, so that the company can easily, easily be saved them, can easily save themselves from, from all these court cases and all that, and for all these claims. So this is how the machine learning works, and this is how the company utilizes the machine learning. This is how the company uses the machine learning and all that to do so. Is this clear to everyone? Yes or no? Is this clear to everyone? Yes or no? Come on, guys, tell me. Is this clear to everyone? Yes or no? Exactly. Even the toothpaste as well, right? They also claim that 99% you will not going to get cavities and all that, but still it is very difficult. And one thing you need to understand that you might have heard about this, or you might have read about this during your school days, and whenever you were learning science, that machine cannot be 100% efficient. Machine cannot be 100% efficient. When we say machine cannot be 100% efficient, that means no machine can give you 100% accuracy. No machine or anything around yourself, anything around yourself is not 100% perfect. Okay, according to the law of science, if you talk about science, science says that nothing in this entire universe is 100% efficient. Even though if I create, if I you know even though if I create a straight line as well, right, doesn't matter how much straight it is still not 100% perfect. It is still not 100% perfect. Your mobile phone or telephone, all the shape that this has, right, by with the help of naked eye we cannot see that. With the help of naked eye we say that, okay, it's perfect, it's perfect square, it's perfect round, it's absolutely fine, but still it is not 100% efficient. So you need to understand that you can never ever get 100% accuracy in your model, and none of the organization or anything could be claimed that 100% this is 100 pure 100% and all that. Whenever now, from now onwards, whenever you see, whenever see any products and it's claimed that it is 100% this, 100% and that as well, so always remember nothing could be 100%. There will be always be a loss. There would be always be a loss of something, right? So that's why when we say machine cannot be 100% efficient, it means that machine cannot achieve 100% accuracy. Okay, so you need to try your best to get a maximum accuracy, but never get into under a misconception that you will always going to get 100% accuracy. Till here, is it clear, everyone? Yes or no? Give me a confirmation, please. Is this clear, everyone? Kindly give me a confirmation, please. Okay. So there are a lot of things about machine learning that we could talk, but it will going to stretch our time and take a long way back. What we will going to do, let's go on and move on another topic about machine learning in more theoretical way. When we talk about machine learning, how exactly it has been defined? How exactly it has been defined, right? So if I have to write, let me create another Jamboard. Okay, so machine learning, let me write over here machine learning. Okay, so machine learning is actually a subfield of computer science that will going to give the computer the ability to learn from itself or from its past experience without being explicitly programmed or without the interference of any other third party, right? Now, machine learning is three types. There are three types of machine learning. There are subtypes in machine learning. The major types are, one is known as a supervised learning. One is known as supervised learning. Another is known as unsupervised learning. Another is known as unsupervised learning. Let me stretch this. And third is known as the reinforcement learning. Let me write over here. Okay. So these are the three types of machine learning. These are three types under machine learning, and there are various other type as well. If you go and search, you'll be going to find out semi-supervised and all that. But those are the subpart that has been created from these three only, right? So major ones are supervised, unsupervised, and reinforcement learning, right? But before going on to machine learning, there are a lot of people who create, who has a confusion that what is the difference between data analysis and machine learning? Are they both the same? If I ask you, do you think machine learning and data analysis are same? Do you think that? Yes or no? Come on, come on, come on, tell me guys. Do you think that data analysis and machine learning are same? Absolutely not. Absolutely not. So machine learning and data analysis is absolutely different. Now what happened? If you remember on the first day I was talking about the term data, right? So this data that we get is the filthiest data. If you are feeding this data directly to machine learning, if you are taking this data and directly try to perform machine learning, it will be of no use. It will be of no use because your accuracy that you will be getting will be a very low accuracy. It might be 10%, 5%, and all that. So before going to machine learning, this data has to be processed. It has to go through a process known as data analysis. It has to go through a process known as data analysis, and this data analysis will going to give you another data. Okay, that data is known as the information, and then you take this information to feed machine learning. Now see the process. You cannot take the data and directly start with machine learning. You first have to perform data analysis on that, and then you have, after performing all the analysis, the output that you are getting after performing the data analysis, this will going to be treated as the input for the machine learning. Now many people get confused about machine learning and data analysis. In a very simple form, I would say machine learning is all about predicting features, okay, by looking onto the current data, present data, past data. However, data analysis is limited to present. Data analysis is absolutely limited to present. It will only going to talk about present and past. Data analysis will not going to talk about future. However, machine learning will going to talk about future. That's the only difference between these two. If I need to explain you with the help of an example, I would say that, have you guys have heard about this movie called Spider-Man No Way Home? Spider-Man No Way Home. Anyone? Have you guys heard about this? Spider-Man No Way Home? Any Marvel fan? Right? Perfect. So now what happened is this Spider-Man No Way Home was released on December 2021, right? And the trailer has been dropped on August 2021. The trailer was dropped on August 2021. Right? Now let's do some analysis that when on the first day when we have seen the trailer, I'm talking about the trailer, guys, right? While watching the trailer, we have seen that, okay, in the trailer we will be going to get a Doctor Strange, we'll be going to get the Spider-Man, that is your Tom Holland Spider-Man. We have seen Dr. Ock will be there. Dr. Ock will be there. Okay. We have seen that MJ will be there. We have seen Wong will be there. We have seen what is that? Any other character? Sandman. We have seen, and we have also seen what all character we have seen. Any other character? Electro, right? Electro. We have seen these many characters in the trailer, so that by looking at this I can say that Doctor Strange will going to be there, Sandman, Spider-Man will be there, Electro will be there, and so on and so forth will be there, right? This is how about the data analysis, that you are talking about the current data only. By looking at the data you are talking about present, right? But now see, When we talk about machine learning, now see over here, we have seen, okay, we will be having Electro. Electro was a villain for the Andrews Spider-Man. Sandman, we are going to have Sandman, Goblin, and we are going to have Dr. Oak. These are the villains for the Toby's Spider-Man. So we have predicted that since all these characters are there, then there's a high chance that there will be three Spider-Man. There will be three Spider-Man. This is something that we have predicted. Yes or no? And all the trailers, we haven't seen any three Spider-Man. Yes or no? Yes or no? But based on these features, we have predicted that there will be three Spider-Mans. Are you guys getting this? Are you guys getting this example? Yes or no? Right? So at that point, we didn't know that this will going to happen or not. We was only expecting, we were only analyzing, we were only predicting that based on this information, it could happen that this will going to be the result, right? And after like 3 or 4 or 5 months, we got to know that yes, our prediction was correct. Our prediction was correct, right? There's a high chance, right? But this is known as the machine learning, by the way. This is how, when we talk about future, is known as machine learning. And this is about data analysis when we talk about present data, when we talk about the past data. Till here, is it clear? Till here, is it clear? Yes or no? Till here, is it clear? Come on, guys. Are you guys getting this or not? Okay. Now, this is something that has become true, that, okay, based on this analysis, this has been true, right? Now, this, I've already told you, it is based on probability. Probability means there's a high chance and there's a chance as well to get it declined. That means whatsoever you are predicting, there's also a chance that it will not going to happen. Similar example, if I have to take, you must have heard about a movie, Doctor Strange, Multiverse of Madness. Anyone have heard about this? Doctor Strange, Multiverse of Madness. Anyone? Anyone? Yes or no? Right? In this, and the same way, when the trailer drops up, we have seen a scene, that Illuminati scene. We have watched a scene that states that there will be Illuminati, and based on that, we have predicted that there will be superior Iron Man. Yes or no? Based on that particular scene, we have predicted that there will be superior Iron Man, because superior, according to the comics, so Iron Man is a part of Illuminati. So when we have seen that, okay, there will be Illuminati will going to appear in that movie, so definitely there's a high chance that there will be superior Iron Man, and lot of people were circulating image of Tom Cruise as being that, right? But now what happened is, we were predicting that this will going to happen, but did this thing has happened? Yes or no? Did our prediction was 100% correct? Was our prediction was 100% correct? Yes or no? Absolutely not, because we were expecting superior Iron Man based on the data that was provided, but it didn't happen. It didn't happen, right? So this is the thing that I want to tell you, that probability plays a very vital role in machine learning. Machine learning will always going to tell you about probability. It will always going to give you high chances, right? But it doesn't mean that it is a surety. It doesn't mean it's a surety. Okay, is this clear? Is this clear? Yes or no? Are you guys getting this? The difference between data analysis and machine learning? Perfect. So now let's come back to the topic where we are discussing about the machine learning. There was three types of machine learning, where we have supervised learning, where we have unsupervised learning, and where we have reinforcement learning. Okay. Now, supervised learning, as the name suggests, supervised, right? It means there will be someone for supervision. Supervision means that there will be someone who will going to correct you, like a teacher, right? Whatsoever steps you are going to, whatsoever steps you are going to take, there will be someone to verify or rectify whether the steps that you have taken is correct or not. Is this clear? Is this clear? Yes or no? Okay. So what happens is that whenever we get a data, like that data will going to decide whether you have to go with supervised learning or unsupervised learning. Okay. In that data, if you're getting an answer key, if you are getting an answer key in this data, that means the output, that what going to be the output based on the question paper, what will going to be the answer. In that case, you have to go with supervised learning. In that case, you have to go with supervised learning. But in such cases where your answer key is not being present or your label data is not being present, you have to go with unsupervised learning. For an example, let's say you are having your mathematics exam in the upcoming time, right? So what you did is you took a book, a revision book. Okay, in this book there's a lot of problem statement. So what happened is you have taken a problem, you have taken this problem, you have solved, and let's suppose your answer that you are getting is 19, for an example, right? This book contain question as well, and this book contain answer as well, so that you can tally your answer with the book answer to say, to match whether your answer is correct or not. If your answer is correct, you will going to always remember this, that okay, this is the right method to do this, and we are going to go on to the next question. If this answer is wrong, you will going to understand that what mistake you are doing, and then you will going to do it again. Is this clear? Is this clear? Yes or no? Is this clear? Okay. So over here, this answer key plays a very vital role. Over here, this answer key plays a very vital role. Okay. So that we can understand whether our answer that we are getting is correct or not. Based on that, we are going to increase our learning. Okay. So whenever the answer key has been provided or the label data has been provided, we are going to go with supervised learning. Whenever we are not going to get these label data, we are going ahead with unsupervised learning. This is the first case, right? Now, supervised learning, there are two types of supervised learning. There are two types of supervised learning. One is your regression. One is your regression, okay? And another is your classification. Another is your classification, okay? Let me write this, yeah. Okay, one is your regression and another is your classification. Whereas in unsupervised learning, again you have two types. One is your clustering and another is your association. Okay, so now we are talking about the target value, or we are talking about the label data of the answer key, right? If the value, if the value in the answer key is a continuous, is a continuous or a continuous value, right? Or is a discrete or continuous value or a numerical value, okay? We are going to go with regression. If the value in the output or then the target variable or the label data of the answer key is in a form of a category, right? Then we have to go with classification. Classification focus on the categorical values, whereas the regression follows under the numerical values that could be or discrete or it could be a continuous. Okay, so there are different algorithms under regression. One is your linear regression. Another is your SVR, that is your support vector regressor. One is your decision tree regressor. One is your, let's say, random forest regressor, right? So these all are the algorithm that falls under regression. There are plenty more, but these are the basic ones, right? Similarly, under classification, we have logistic regression. We have KNN, that is K nearest neighbor. We have SVC, that is your support vector classifier. We have DTC, that is your that is your what was that? Yeah, we have RTC and DTC. RTC is your random. What was the RTC? Am I audible to everyone? Am I audible to everyone? Yes or no? Okay, so DTC over here is your decision tree classifier. Over here, since we have DTC, DTR as decision tree regressor, we have DTC as decision tree classifier, and RTC as a random forest classifier, right? This is how you have, these are some of the algorithms that you have under classification and regression, right? And which algorithm to choose and everything will going to be decided by your target value, target variable. Okay, target variable means your answer key. Okay, when we talk about unsupervised learning, we have two part. When we have clustering and association. Clustering and association are totally focused on understanding the customer behavior. These two part of unsupervised learning or unsupervised is being widely used by different e-commerce websites such as Amazon, Flipkart, Alibaba, Airbnb, and many other flight organization or e-commerce organization, and many more companies, right? So in clustering we have mean clustering, and in association we have a priori and eclipse. We have a priori and eclipse in this clustering and association, right? So unsupervised learning is totally focused. Full form of RTC is full form of RTC is your random forest, not RTC. It should be RF. Sorry, it should be RFC. Sorry, random forest classifier. Okay, it is RFC. Okay, so most of the company uses the unsupervised learning for their for their increment in their revenue, and to publish their different products among the customers and all that, right? Now the last type over here is your reinforcement learning. Now reinforcement learning is totally based on the game theory. Reinforcement learning is totally based on the game theory. Like suppose we play a game, right? So the same method or same example of the game has been taken and has been applied in the machine, right? For an example, for an example, let's say you are playing the game Mario for the first time. You're playing a game Mario for the first time, and you're playing, and suddenly an enemy appeared in front of you, and since you are playing it for the first time, you don't know how to tackle this enemy. So what happened? This enemy will going to touch you and you are going to die. So now what will going to happen? Based on this example or this scenario, this experience, you get an idea that you have to try your best not to get touched by this enemy, otherwise you are going to get killed. Yes or no? Yes or no? Yes or no? Getting this or not? Okay, so again you will going to play, the Mario, and you will going to find out, let's suppose over here you are having a star. You don't know what happened with this star. So what happened? As soon as you're going to touch this, you are getting some superpower. Okay, and you are getting the superpower, and this will going to create another experience that this is something good, and by doing this action I am getting benefits, right? So again and again, whenever I'm going to play, I'm going to try to achieve this kind of stuff. So this is a game theory that is applied in the reinforcement learning, that you are going to create a machine, and this machine will going to perform some action, and based on this action it will going to decide whether the action that has been taken is good or bad. If it is good, then machine will going to go ahead. If the action is bad, then machine will going to try to improve itself and will going to define another way or a actual way. Okay, now what happened is that during the last decade, Google was working with reinforcement learning, and they have created a machine known as Alphago. They have created a machine known as AlphaGo. Okay, that was based on reinforcement learning. So Go is actually a game. It's a board game, such as we have chess, right? We have chess, checkers, and all that. So similarly, Go is also a game. So what happened is that they have created a machine, and they have trained the machine so that it can play. It can play the entire part. It can play the entire game. Okay, Now they have introduced a tournament. They have introduced a tournament with the champion of this game Go. So they had a 5 matches, among which 4 match was won by machine, 1 match was won by human. Okay, it has a beautiful documentary on YouTube. If you go on and search, you will going to get that. Okay, is this clear? Okay, so that was totally based on reinforcement learning. That was totally based on reinforcement learning, and with the help of this, you can create multiple machines based on that will going to learn from its previous experience and try to make it better. Is this clear? Is this clear? Is this clear, everyone? Yes or no? Okay, so this is just a brief about machine learning, what exactly it works and all that. And this is not something that is only about machine learning. You have a lot of things about machine learning, and most of the important things is your mathematics. You should be good in mathematics, you should be good in stats, then only you can easily work out with machine learning algorithm, because in machine learning you have to understand how exactly the algorithm works. Okay, you need to understand that how exactly linear regression work, how SVR, DTR, and RFR works, what are the formulas they use to have to work out, okay, and how you can optimize it and improve its performance, and how you can tune the value, right? So these are some of the advanced concepts. But in this session, I hope that everyone get an idea of how machine learning works and how exactly what are the difference between all of this two. So in this series, we are going to talk about the linear regression. We are going to focus on the linear regression model. Linear regression model is a very simple algorithm. It's a very simple algorithm. So we can start it with instantaneously. Tomorrow we are going to talk about the theoretical part of linear regression, and we are going to perform the practical implementation of linear regression. And day after tomorrow, we are going to try to see how to deploy it with Flask. Okay. So that's all for today. Is this clear? Is this clear, everyone? Yes or no? Is this clear, everyone? Yes or no? Perfect. So here you go for the attendance. So this is the attendance. Don't forget to mark your attendance on this form. Kindly go ahead and try to mark your attendance. If you guys have any doubt, kindly ask. If you guys have any doubt, kindly ask your doubt, please. Okay, if I have to summarize what we have studied today, we have talked about machine learning. We have seen how exactly company uses machine learning algorithm, how machine learning is different from DL and AI, and how where exactly machine learning stands among them, and how you can use the machine learning, how machine learning works, what is the prediction, what is the probability. We have understood about the difference between data analysis and machine learning. We have seen how many types of machine learnings are there, and what are the different algorithms are there, and when to use which algorithms. Okay. Is this clear? Is this clear, everyone? Is this clear, everyone? Yes or no? Come on. Okay. Perfect. If you guys have any doubt, kindly ask. We could have extended the session. However, I don't feel like that other people want it to be extended. So let's stop it here itself. See, reinforcement learning is a type of machine learning which follows the game theory. Okay. So in a game, when we do something good, we get some points and we feel better. And when we, do something wrong or which is unexpected, we our points get cutted off and all that, and we have to bear a loss. So based on that, machine learns itself to make a decision they will going to perform some decision, they will going to act something, and then they will going to check whether their action is a profitable action or it is a loss action. If it is profitable, then they will going to go ahead with another check part. If it is not, then they will going to improve themselves and will going to learn from their past experience to get a more accurate result. Okay, if you don't know flaws, you can still complete the project, don't worry. Okay, is this data enough for machine learning? Kindly elaborate this. I didn't get your question. What kind of data are you referring to? Which one is better, either AI or ML? See, never ever compare technologies. Never ever compare technologies. Every technologies is best at its own pace, right? AI and ML is absolutely different, right? So you cannot compare that which is better. AI is better or ML is better. So kind of don't compare. Okay. Any other doubts? Any more doubts, guys? Okay. Any more doubts? Reinforcement learning is a part of machine learning. Okay. What is Python? I believe that you should need to see, the day one session. In that, I have explained what is Python. Okay, Python is your programming language. Sir, I am working one project in the machine learning using the Python and its temperature prediction. Any suggestion for me? What do you want me to tell you about? You need to specify, right? We are going to take a data set similar to this temperature part, ice cream temperature. We are going to perform data analysis on that in the upcoming time, so you can take the reference from that. Okay. Can I attach the certificate in my resume? Sure, you can. Okay. See, ML is a subset of AI. Okay. So ML focuses on the learning curve, how exactly human, what is it exactly is a human behavior and how they learn. Whereas AI is a very vast field that focus on the entire functioning of a human, right, and try to create it in a form of a robot. Okay. Okay. In that case, I feel. Uh, what are the disadvantage of, see, the disadvantage of machine learning is that it always follows a pattern. Okay, but in cases we have seen that when we talk about human never follows a pattern whenever they makes a decision, right? There could be a lot of things. So that's why we have DL to improve the disadvantages of machine learning. Okay, perfect. Data science and deep learning is absolutely different. Deep learning is a part of machine learning, right? Whereas data science is a very vast field. It includes deep learning, it includes machine learning, it includes AI, it includes full stack, cloud, DevOps, and all that. So they both are absolutely different. Okay, so I feel that that's the end of the session, and let's meet tomorrow. And we're going to start with the linear regression, both the theoretical and practical implementation as well. Okay, so thank you so much, guys, for joining in. Let's meet tomorrow. Till then, enjoy your evening and have a great time. See you all soon and be safe. Thank you, guys.